Hello students, this is Shailaja Vibhute. Today let us start third chapter, that is motion in a straight line. When we can say body is at rest, a body is said to be at rest if it does not changes its position with respect to time. Similarly, when we can say body is in motion, body is said to be in motion if it changes its position with respect to time. Correct. Now let us take types of motion. One-dimensional motion, two-dimensional motion, three-dimensional motion. In short, you can take it as 1D, 2D and 3D. Okay. So what is one-dimensional motion? Or that only motion in a straight line, or one more word is there, that is rectilinear motion. So what is one-dimensional motion then? It is the motion of a body along a straight line. Okay. So what is motion in a straight line then? Very simple one. If a body is moving along a straight line, then it is known as one-dimensional motion. For example, the motion of a stone dropped from a height. Okay, second type is two-dimensional motion. Or say you can say it is motion in a plane or curvilinear motion. It is the motion of a body in a plane or along a curved path. Example for two-dimensional motion is motion of a shot put thrown by an athlete, a body moving in a circular path. Okay, these are examples for two-dimensional. Now three-dimensional motion is very simple. It is motion of a body in space. Examples are also very simple. A bird flying in space, an aeroplane moving in space. Okay, fine. Now to make our study easy, we have to learn some terms here, that is about mechanics. Okay, so mechanics, statics, dynamics, kinematics, kinetics, these are some words which are related to one-dimensional motion. What is mechanics then? It is the branch of physics, deals with the study of objects at rest and in motion. So you are going to study about the objects which are at rest and which are in motion. That's why mechanics can be divided into two parts. One is statics, another one is dynamics. So very simple one. See the word here, static. So static is nothing but very easy to understand. It deals with the study of objects at rest under the action of forces. Similarly, dynamics means it deals with the study of objects in motion under the action of forces. Again, this dynamics is divided into two groups. One is kinematics, another one is kinetics. Say if a body is moving, only we will study about some words like speed, velocity, distance covered, without asking any reason why that body is moving. So all those will come under kinematics. So what is kinematics then? It is branch which deals with the study of objects in motion without considering the cause for the motion. Cause means reason, without asking the reason why that body is moving. So if we study in detail, that branch will come under this kinematics. Then kinetics is nothing but here you are going to ask the reason why that body is moving, in which direction it is moving, all that you will ask. So it is branch of physics which deals with the study of objects in motion by considering the reason for the motion. That will come under kinetics. I hope these words are clear. Mechanics is divided into two, statics and dynamics. In statics, bodies at rest. In dynamics, bodies are in motion. Dynamics again it is divided into two, kinematics, kinetics. In kinematics, no reason, why that body is moving without asking, we can study. In kinetics, with the reason why that body is moving, we are going to study. So now whatever definitions I have given, that only it is given in this slide. You can go through it. That is, mechanics is branch of physics which deals with the study of objects at rest and in motion. Similarly, about statics, dynamics, kinematics and kinetics. Okay. Now let us see very interesting one, that is about distance. Very easy word. Already we know about distance, displacement, correct? Okay, now let us see about distance. Distance is the total path covered by the body during the motion. Means it is path covered by the body. These are some say points which are related to distance. Since only path covered you are concentrating, means it becomes a scalar quantity. Its SI unit is meter, and if you want to write the dimensional formula, it will be m raised to 0, L raised to 1, T raised to 0. Here it is, by mistake it is, you take it as T raised to 0. Only distance, path covered. So it is L raised to 1 you have to take. M and T are 0. Wait one second, one more time I will write. This term, here mistake is there. So you make it as T raised to 0. Okay. So M raised to 0, L raised to 1 and T raised to 0. It is dimensional formula for distance. Okay. Now let us go for next one, that is displacement. Displacement, very interesting one. It is the shortest distance between the initial and final positions of the body during its motion. Try to understand. Displacement, actually you can define it in another way. It is path covered by the body with reference to direction. So like that also you can define, or it is the shortest distance between initial and final positions of the body during its motion. Try to remember the definition so that you can understand next points. Since displacement has direction, so it is a vector quantity. Its SI unit is meter. Again, its dimensional formula is same as that of distance. That is m raised to 0, L raised to 1 and T raised to 0. Okay. Here again it is a mistake. So you make this one as T raised to 0. Fine. Now see one more point. When a body moves along a straight line in the same direction, always distance will be equal to displacement. This point will be very clear to you when we will go for next slide. To understand the difference between distance and displacement, here one diagram is drawn, very simple one. See, it is from point A to point B. Okay, so to move from A to B, you can follow any type of path. Here one path is given. See, now this is path covered from A to B. Anyhow you can reach, or say you can take one more path like this. Say to reach from, means to move from A to B, you can go like this also, correct? So this is distance. But from initial point to final point, if you take, it becomes displacement. Okay, so it is the shortest distance between initial point and final point. What is this? This is displacement. Distance can be even this also. That's why if you see the last point, see this point. Which one? When a body moves along a straight line in the same direction, distance is equal to displacement. I hope you understood the point now. Okay. Now in this slide, here one simple problem I had taken only to get the difference between distance and displacement. What is that? Let us read. A man moves from point A to point A to point B, then to point C, and finally to point D as shown in the diagram. So a man is moving from A to B, then B to C, then C to D. Okay. Find the distance and displacement traveled by the man. Now you have to find out distance as well as displacement. So very simple one. Distance means path covered. So A to D, first A to B, how much it is? 50 meter. B to C, it is 30 meter. Again C to D, it is same as this one, it is again 50. So 50 plus 30 plus 50, C to D, how much you will get? 130 meter. Okay, this is distance. Total path covered you are taking A to B, B to C, C to D. Fine. So 50 plus 30 plus 50, you will get 130. Now what about the displacement? Displacement, according to the definition, it is the shortest distance between initial point and final point. According to the problem, initial point is A and final point is D. So what is distance between A to D? In the diagram, since it is a rectangle position, so A to D is nothing but it is same as B to C. So A to D is, it is 30 meter, and if you want to show the direction, it will be towards the north. Okay, so what is displacement now? Displacement value is 30 meter. Initial position is A, final position is D. Distance between A to D is 30 meter. I hope it is very clear now. Now let us move to one more example. Okay, just observe this one. It is the best example to understand the difference between distance and displacement. Say here tossing an object you take. Okay, this you can take it as a ball or a marker, okay, or a coin you can take. So first that ball, it is in the hand, then it is thrown. Okay, say it has covered a distance like about 1 meter, you can say. Okay, when it is thrown up, it is 1 meter. Again that ball is coming back to the same position, same hand. It traveled some distance, again it is coming back. Okay, now if I ask what is the distance covered? How much I told? 1 meter it will cover. Okay, when it is thrown up. So again it will come back. So maybe some students are answering like distance is about 2 meter. Okay, now what about the displacement? Any answer? Any guesses? Okay, so I think all are very intelligent. So displacement of the object is 0. Correct? How it is? What is the initial position of the body? It is the hand, correct? And it is returning back to same hand you are taking. So initial position and final positions are same. So difference between or distance between initial position and final position is displacement. But since both are same here, that's why it is 0. So this is very simple example which shows the basic difference between distance and displacement. I hope you have understood. Okay. Now in exam, they'll ask distinguish between distance and displacement. Here I have listed 4 points. You can remember any 2 so that you can answer the question because it carries 2 marks. In distance side, it is the actual path between initial final position of the body during motion. Displacement is the shortest distance between initial and final positions. Distance is scalar quantity, but displacement is vector quantity. Now see the third one, very important one. It is never 0 or negative, but it is always positive. Which one? Distance. But displacement, it may be 0. Just now we have seen in one example, displacement is 0. Or it is positive, or it may be negative also. When it will be negative, that we will see in the next one. Okay. Then fourth point is in a given interval of time, distance may be equal to or greater than the displacement, but never less than displacement. Correct? This point is very interesting one. In a given interval of time, displacement may be equal or less than the distance, but never greater than distance. Okay, displacement is, it may be equal to distance, but it is never greater than distance. Always it is less or equal to distance. So I hope you have understood all these basic things. Let us continue. Thank you.